This is a walkthrough of the A-level Paper 1, Pure Maths Paper 1. Question number 1. Figure 1 shows a sketch of the curve with this equation: y is equal to x over 1 plus root x. The finite region R is shown shaded in figure 1 and is bounded by the curve at the top, the line x equals 1 on the left, the x-axis at the bottom, and the line with equation x equals 3 on the right hand side. The table below shows the corresponding values of x and y for the same equation. So each value of x has been substituted in the equation and give us these values of y, and it looks like they've been rounded to 4 decimal places. Using the trapezium rule with all the values of y in the table, find an estimate for the area of R. So the trapezium rule is always going to be an estimate, giving your answer to 3 decimal places. So the first thing I'm going to do, if I don't know the trapezium rule off by heart, which is fine, we can look in the formula book and write it down. So I'll write it down now. Okay, so it's here, ready. All we need to do is to substitute in the values. So we've got our estimate for the area of R is half times h. Now h is going to be the height of the trapeziums. Now remember, when we use the trapezium rule and we divide up the area into trapeziums, these trapeziums are on their side like this. So the height goes across like this. So the difference in the x coordinates is going to give us the height. So if we look at these x values, they're going up by 0.5. So you've got 1, 1.5 here, 2, 2.5 and so on. So the height of each trapezium is going to be 0.5. So you look at basically the difference in the x coordinates. Then we add together the first and last y value, that's y0 and yn. So that's going to be 0.5 plus 0.6742. And then we're going to add to that 2 lots, or 2 times the sum of the other y values, the ones in between. So 0.6742 plus 0.8284 plus 0.9686. Now I've already calculated this on my calculator and I get 1.635125. Now it does say I need to round it to 3 decimal places, so that's going to be 1.635. So 1.635 will be my answer for part A. Part B, explain how the trapezium rule can be used to give a better approximation for the area of R. Well, by dividing the area up into more trapeziums, in other words, decreasing their width. So we've got bigger table, the jump between the x coordinate is less. That would give a better estimate. So I'll just write down by increasing the number of strips. Part C. Given your answer to 3 decimal places in each case, use your answer to part A. So we're going to be using this answer from part A to deduce an estimate for, in the first case, this integral here. So the first thing I'm going to do is actually just write down what the integral was that we worked out in part A. And that was an integral between the limits of 1 and 3 of x over 1 plus root x. And what I want to do is to compare that to what I've got here. And actually what I've got in the first part of part C, let's write it down here, is basically this times by 5. So what I'm going to do is to write that integral that's given, 5x over 1 plus root x dx, is equal to 5 times, so I can put the 5 on the other side, x over 1 plus root x dx. Now, I've got an estimate for this, haven't I? 1.635. So I can say that an estimate for this area is going to be 5 times by 1.635. And that gives me 8.175. Let's write that a bit neater. 8.175. We're going to do something similar in the second part of part C. Again, compare the integral that they've given with the one that we've already got. And here I've basically got the same integral but plus 6. Okay, so what I want to do, like the previous question, I want to split this integral up so I get part of what I got from part A. So this can become the integral between 1 and 3 of 6 dx plus the integral that we got an estimate for in part A. Okay, so I've got an estimate for this part here, so I know that is the 1.635. So I need to do something with this part here, and that's a very simple integration. So 6 integrated with respect to x will become 6x. My limits are 1 and 3, so that will be 6 times 3 minus 6 times 1. That's going to be 18 minus 6, so that is equal to 12. So this integral that I'm trying to find an estimate for the area for, let's put dx on the end. Actually, I don't need a bracket here. Let's put a bracket at the front there. That's equal to this bit which we worked out, which is 12, plus the 1.635 we got from part A. So that gives us 13.635. Question 2. Show that the binomial expansion of 4 plus 5x all to the power half in ascending or increasing powers of x up to and including the x squared term is 2 plus 5 over 4x plus kx squared, giving the value of the constant k as a simplified fraction. Okay, so I've got the first part of the binomial expansion written down here. So first we need to do is to write our bracket in this form. So we want 1 plus something x. So we can have a number there, that's fine, but we need to make that first number 1. So the way we're going to do that is start by taking out 4 out of the brackets. So that will give me 1 plus 5 over 4x in the brackets. Now remember, all of this is to the power half, not just the second bracket or the inner bracket. So that's 4 to the power half times by, using rules for powers, 1 plus 5 over 4x to the power half. And it's the second part here that we're going to do the binomial expansion on. So it's basically going to be 2, because 4 to the power half is 2. 2 times by whatever I get for my binomial expansion. And when I do my binomial expansion, I'm going to substitute every x in the binomial expansion for 5 over 4x. And I'm going to substitute any n in the binomial expansion. I'll substitute that for a half. So now the next bit is just substitution into here, and I only want to go up to the x squared term. So basically it's the first three terms here. Right, so the first term is just going to be 1. So don't forget it's going to be 2 times by this expansion. So 1 plus nx, or n is a half, and x I'm replacing with 5 over 4x, so there's my nx. Then the next term is n, half, times by n minus 1, that's half minus 1, so that's minus a half, over 2 factorial, and I'm replacing my x squared with 5 over 4x all squared. So it's not 5 over 4 with just the squared on the x, but all of that, because I'm substituting x with all of 5 over 4. So the next step is just to simplify this. So let's simplify the brackets inside first before we times by 2. So I'll have 1 plus, now I think the next term will be 5 over 8x, 5 over 8x. Then the next term, if I do half times negative a half, that's negative a quarter, and then divide it by 2 factorial, divide it by 2, and then times it by 25 over 16. That gives me negative 25 over 128 x squared. Okay, now I don't need to go any further, but I do need to times it by 2. So that'd be 2 plus, if I times this by 2, that will be 10 over 16. Now I need to give, well, I want to simplify all my answers. So 10 over 16, sorry, 10 over 8, almost just gave an equivalent fraction there. So 10 over 8 simplified will be 5 over 4, so 5 over 4x, and then multiplying this by 2, so 50 over 128 is going to be 25 over 64, so minus 25 over 64 x squared. And the question is about giving a value of k as a simplified fraction. So we've done that. They don't just want the value of k, they want the whole binomial expansion. And here we go. That's part A done. Part B. And the first part of part B. Using the expansion from part A with x equals 1/10 to find an approximate value for the square root of 2, giving your answer in the form p over q, where p and q are integers. Right, so first of all, I'm going to put x is a half into this, the actual value, to see what it gives me the square root of. It may not necessarily give me the square root of 2, so I may need to manipulate what I get when I put half into the expansion. Right, so 4 plus 5 times, sorry, not a half, 1 over 10 to the power of a half. Let's see what that gives us. And that gives us 3 over root 2. Okay, so actually putting 1/10 into here doesn't give us root 2, it gives us 3 over root 2. So putting 1/10 for x is going to give us 3 over root 2. We're going to have to rearrange that to make root 2 the subject. It's easy enough to do. So let's take our expansion. So 2 plus 5 over 4x, which is 1/10, minus 25 over 64 times by 1/10 squared. This is giving us an approximate value for 3 over root 2. So I just need to rearrange it so I can find an approximate value for root 2. And that's going to be 3 over 2 plus 5 over 4 times the 10th minus 25 over 64 times 1/10 squared. Now the fraction that gives me on the calculator is 256 over 181. There's no point pressing my SD button because we need to give our answer in the form P over Q. So here P is 256 and Q is 181. Okay, so second part of part B says here, explain why substituting x equals 1 over 10 into this binomial expansion leads to a valid approximation. So we need to have a look at the expansion that we did and see what it's valid for. Now to do that, we need to look at what we actually expanded. We actually expanded this, and you look at this part here, the 5 over 4x, whatever that is, that needs to be less than 1, or between 1 and minus 1. So the modulus of 5 over 4x needs to be less than 1. We'll rearrange that. So we can times both sides by 4, divide both sides by 5, and we get the modulus of x is less than 4 over 5. In other words, the expansion that we did is valid for the modulus of x is less than 4 over 5, and then we can say that since our half is in that range, which we could write as the modulus of x is less than 45, the expansion is valid. Question 3. A sequence of numbers A1, A2 and A3 is defined by this rule here. A1 is equal to 3, so the first number in the sequence is 3. And to find the next number in the sequence, AN plus 1, we take the previous number, we subtract 3, and we divide by the same previous number minus 2. And this is valid for all values of n where n are integers. And what we need to do in part A is to find the sum of AR from R equals 1 to 100. Now on these types of questions, there's always going to be a quick, easy way to do it. We're not going to write out all 100 terms and find the sum. What we are going to do is start by writing out maybe the first few terms and then see if there's a pattern which allows us then to work out what the sum of those 100 terms is. So we already know that the first term, A1 or A sub 1, is 3. We're now going to work out the second term. So the second term is the previous term, which is 3, minus 3 over the previous term minus 2. So that just gives us 0 over 1, which is 0. Okay, so I'm just going to make a list of the terms over here. So first term is 3, second term is 0. Right, let's work out the third term, A3. So it's the previous term, 0, minus 3, over the previous term, 0, minus 2. So that gives me minus 3 over minus 2, which is just 3 over 2. So the next term is 3 over 2. Okay, let's work out A4. So A4 is going to be the previous term, 3 over 2 minus 3, over the previous term, 3 over 2 minus 2. And that gives me 3. Now, as soon as I put 3 in to find A5, I'm going to get 0. And I'm going to go around the loop again. So there are 3 numbers in this loop. A1, A2, A3, A4, A5, A6, A7, A8, A9, and so on. So this is going to make it very easy to find the first 100 terms. So in these 100 terms, I'm going to have 33 of these terms. I'm going to have 33 of these and 33 of these. That only takes me to the 99th term, and then I'm going to have this first term once. So if I want to find the sum of these first 100 terms, it's actually equal to 33 times by the first term, that's going to occur 33 times, plus 33 lots of that second term in that repeating pattern which has a period of 3, plus 33 of those 3/2's. That's only going to give me 99 terms, and then the 100th term is going to be the 3. So all I need to do is add all of these up. So that's just going to be 99 plus the 0 plus 99/2, which is the same as 49.5 plus 3, and that is 151.5. And then part B, it says hence find this, the sum of the first 100 terms, then the sum of the first 99 terms. Well, I've already worked out this, haven't I? Yeah, so I know that already is 151.5. Now if I want to find the sum of the first 99 terms, that is basically, let's colour code it, so the sum of the first 99 terms is this part here, without the 3 added on at the end. So that should be quite straightforward to work out. So the sum of the first 100 terms AR plus the sum of the first 99 terms is equal to 151.5, which I've worked out already, plus basically this part here, which is going to be 3 less than this, and that's going to be 148.5. And that gives me exactly 300. Question 4. Relative to a fixed origin O, the point A has position vector I plus 7j minus 2k. The point B has position vector 4i plus 3j plus 3k. The point C has position vector 2i plus 10j plus 9k. Given that ABCD is a parallelogram, what we need to do in part A is find the position vector of point D. The first thing I'm going to do is just draw out a sketch of a parallelogram so that I can label it and I can see what's going on. So don't take this literally. It doesn't mean this is exactly what it looks like. This is just to help me visualize what's going on. Then I'll label the vertices A, B, C, D like this. Make sure they're labeled in the same order they're given, A, B, C, D, A, B, C, D. So you should be going around either clockwise or anti-clockwise. You can start A anywhere, it doesn't matter. And what I'm going to do now is to write down the coordinates of each vertices, but I'm going to write it in column form. I just find that a little bit easier than IJK. So A is 1, 7 minus 2. B is 4, 3, 3. And C is 2, 10, 9. And I need to work out what D is. Now, because this is a parallelogram, the opposite sides are parallel and they're the same length. So the displacement that takes me from B to C is the same displacement that takes me from A to D. So if I can work out the displacement from B to C, I can add that displacement to vertex A to find vertex D. So let's start by working out this displacement that takes me from B to C. Now there are two ways we can do it. You can either work out the jump that takes you from 4 to 2, 3 to 10 and so on, or you can take the second vertex, second point, and subtract the first one. Either one will give you the same thing. I'm going to use jumps. So 4 to minus 2 is a jump of minus 2. So that's from there to there. 3 to 10 is a jump of plus 7. And 3 to 9 is a jump of plus 6. Okay, that's my displacement. That is equal to the displacement that takes me from A to D. So if I now take my point A, 1, 7 minus 2, and add that displacement, negative 2, 7, 6, that will give me point D. And that's going to be 1 minus 2, which is minus 1, 7 plus 7, which is 14, minus 2 plus 6, which is 4. So that is the position relative to the origin of D. Minus 1, 14, 4. Part B. The vector AX has the same direction as AB. Given that AX, the length of AX is 10 root 2, find the position vector of X. So if it's got the same direction as AB, it means it's some sort of multiple of this vector AB. And we want to work out what that multiple is by working out what AB is and then its length. So first of all, let's work out the vector displacement vector that takes me from A to B. And the way that I do that is either by doing a jump or position B minus position A. Using jumps, 1 to 4 is a jump of 3, 7 to 3 is a jump of minus 4, and negative 2 to 3 is a jump of 5. Let's now work out the length of this vector, and we're going to use that to compare it with the length of AX. So we just use Pythagoras, so it's going to be the square root of 3 squared plus negative 4 squared, or 4 squared plus 5 squared. That's square root 50, and that is equal to 5 root 2. So that's the length of AB. Let's compare that to AX. AX is twice as long. AX, the length of AX, is equal to 2 times the length of AB. What does that mean? That means that the vector AX is double the vector for AB. So let's carry on, and we'll write down here that AX is equal to 2 times AB. So that is 3 minus 4, 5. So the vector AX is 6 minus 8, 10. But we're not finished, because this is the displacement from A to X. We need to find X. So just like before, like what we did in part A, if I take position A, add this displacement, I'll get position X. So I need to get point A, which is 1, 7 minus 2. Add a displacement to get to X, which is 6, negative 8, 10. And that will give me position X. So 1 plus 6 is 7. 7 minus 8 is negative 1. Negative 2 plus 10 is 8. So that is the vector position of X in column form, or if you want to write it in IJK form, because that's the form we were given in the question, that would be X is equal to 7I minus J plus 8K. So either answer, I mean the question doesn't state whether it needs to be in column form or IJK form, or even as a coordinate. So any one of those forms would be fine as your final answer. Question 5. We have a function f of x is equal to x cubed plus ax squared minus ax plus 48, where a is a constant. Given that f of minus 6 is equal to 0, what we need to do in the first part of part A is show that a is equal to 4. Now, f of negative 6 minus 6 equaling 0 basically means if I substitute negative 6 for x into that function, so negative 6 cubed plus a times by negative 6 squared minus a times by negative 6 plus 48, I know that is equal to 0. So let's simplify this. So negative 6 cubed is minus 216. Then we will have plus 36a, and then plus 6a plus 48 is equal to 0. If we collect our terms together, that will give us 36a plus 6a, so we've got 42a is equal to, so if I move the 216 and 48 over the other side, on the other side I'll basically have 216 minus 48, which is 168. If I divide both sides by 42, so I have 168 divided by 42, I get 4. So I'll just write a equals 4 as required. Moving on to the second part of part A, it says express f of x as a product of two algebraic factors. Now I know that a is 4, I can write down that f of x is equal to x cubed, and replace the a's with 4, plus 4x squared minus 4x plus 48. And since I've been given this information that f of negative 6 is equal to 0, so since f of negative 6 equals 0, that means that x plus 6 is a factor. So I know that I can write f of x equal to x plus 6 times by something else that's going to give me this part here, x cubed plus 4x squared minus 4x plus 48. Now it has to be starting with x squared, because that's going to multiply out to give me x cubed, and I know that the number at the end has to be 8 to give me the 48, so I can put those in. I just need now to work out what the middle term is. Now there are different ways of doing it, but I'm going to say, right, I know that if I multiply the 6 by x squared, that's going to give me 6x squared, but I want to take off 2 lots of x squared. How am I going to get that? By putting minus 2x in the middle here. Now you could use long division, but if you can sort of reason and work it out, that will be a quicker way of doing it, but long division would also work. So here's f of x as a product of two algebraic factors. Right, moving on to part B. Given that 2 log to the base 2 x plus 2 plus log to the base 2 x minus log to the base 2 x minus 6 equals 3, show that x cubed plus 4x squared minus 4x plus 48 is equal to 0. Right, so we're going to be using the rules of logs to get this into the required form. Right, so first thing, whenever you've got a number at the front, that can be written as a power. So we'll have log to the base 2 x plus 2, and the 2 becomes squared, plus log base 2 x minus log base 2 x minus 6 is equal to 3. Next step, rules of power say that when you're adding and subtracting, they become multiply and divide. So I can put all of these together and write it as log to the base 2 of x plus 2 all squared times x, because we're adding here, and then divided by x minus 6, because we're subtracting, is equal to 3. Right, next step is now to write this as a power. So we're going to turn the log into the power. So basically it becomes 2 to the power 3 is equal to x plus 2 all squared times x over x minus 6. Right, so now we're ready to simplify this as much as we can. I'll do it over here on the left, and I'll start by expanding the brackets that I have up here. So that's going to be x times by x plus 2 all squared, so that's going to be x squared plus 4x plus 4 all divided by x minus 6 is equal to 8. Then from here I'll expand these brackets at the top and multiply both sides by x minus 6. So I'll have x cubed plus 4x squared plus 4x is equal to, that's going to be 8 times by x minus 6, which is 8x minus 48. Then bringing everything to one side, I'll have x cubed, then plus 4x squared. Take away 8x from both sides, that'll give me minus 4x, and then add 48 to both sides. That leaves me with 0, so I get what they want as required. And then lastly, part C says, hence explain why that same expression that we had here, I'm not going to read it all out again, has no real roots. Right, to help us do that, we need to look back at what we've got here. So we can work out the roots from this, see if they're roots, and see if there's any problems. So let's start with this part here. So if I've got x plus 6, one root would be x equal to negative 6. Now let's see if we can actually use that in here. If I made x equal to negative 6, I would end up doing the log of minus 4 here, and the log of negative 6 here. We can't do the log of a negative number, it's not defined. So no roots here, or no roots with x equals negative 6, as we cannot do the log of a negative number. And now we'll look at the other part that it's factorized into, and that's the x squared minus 2x plus 8. Let's see if this has got any roots at all. So we can work out the discriminant. So we'll do b squared minus 4ac on that x squared minus 2x plus 8. So if we do that, b squared will have negative 2 squared minus 4 times a, which is 1, times by c, which is 8. That will give us 4 minus 32, so we'll get negative 28. So that part has no real roots. Okay, so x squared minus 2x plus 8 has no real roots. So basically from both of those parts, that original expression here has no real roots, because we can't do the log of a negative number, so that's no good as a solution to this. And x squared minus 2x plus 8 has no real roots either. So there are no real numbers that we can put in for x. Question 6. Figure 2 shows the entrance to a road tunnel here. The maximum height of the tunnel is 5 meters, and the width of the base of the tunnel is measured as 6 meters. Figure 3 shows a quadratic curve BCA over here used to model this entrance. The points A, O, B and C are assumed to lie in the same vertical plane, and the ground AOB is assumed to be horizontal. What we need to do in part A is find an equation for the curve. So the first thing I'm going to do is to write down what the coordinates of the points A, B and C are. Now the height of the tunnel is 5 meters, so we'll call this coordinate at the top, or the y coordinate 5. The width of the tunnel is 6 meters. We've got the y-axis basically going straight down the middle, so it's going to be 3 meters either side of that middle line, that line of symmetry. So it's going to be 3 here and 3 here, or -3. So first thing I'll do is write down those coordinates. So coordinate A is -3, 0. Coordinate B is 3, 0. And coordinate C is 0, 5. And I'm going to use those to find my quadratic. Any quadratic is of this form. Y is equal to ax squared plus bx plus c. And I'm going to substitute in each one of these values, or these coordinates, to find my values of a, b and c. So I've got 3 unknowns, and I'll be able to form at least 3 equations here. So let's put point A in, coordinate A, and that will give me 0 is equal to 9a minus 3b plus c. And put in coordinate B, and that will give me 0 is equal to 9a again plus 3b plus c. And if I put in coordinate C, that will give me 5 is equal to just C, because everything else with an x will become 0. So there we go, straight away I've got the value of C is 5. Now I can use this value of C and put it into both of the previous equations that I've got. So that will give me 9a minus 3b plus 5 is equal to 0. And what I'm going to do is actually move that to the other side and write it equal to minus 5. Then I've got 9a plus 3b is plus 5 is 0. And again, I'll move the 5 over to the other side, take away 5 from both sides. So I've got this equals -5. Now I can solve these simultaneously by adding these two equations together. I'll get 18a is equal to -10, and then from this I will get a is equal to -10 over 18, which is equal to -5 over 9. So I have my value of a, and I can use that value of a and substitute that into either one of these two equations here to find the value of b. Now I'm going to substitute it into the the bottom one, because there are less negative signs. It doesn't really matter. And if I do that, I'll get 9 times by a, which is now -5 over 9, plus 3b is equal to -5. So that will give me -5 plus 3b is equal to -5. Add 5 to both sides, and I'll get 3b is equal to 0, and that gives me b is equal to 0. So that's my last value. So my quadratic now, with those values of a, b and c that I've got, is y is equal to a squared, a is -5 over 9, plus bx, well b is 0, plus c, and c is 5. So there's my quadratic, oops, not equal to 0, that models that tunnel. Part B. A coach has a height of 4.1 meters and a width of 2.4 meters, and what we need to do is determine whether or not it is possible for the coach to enter the tunnel. So it's about taking these values and putting them into our quadratic. Now we need to think about what the values of x and y are. Now the height, that's fine, that can just be y. the width. Now if the width is 2.4, that's all the way across, then the actual x value that I want to put in is going to be 1.2, because that's the distance from the centre of the tunnel to the edge. So we need to do 2.4 divided by 2, 1.2. This is going to be our value of x, which we substitute into the quadratic, and we're going to see what that gives us for the value of y and compare it to 4.1. So I will have y is equal to minus 5/9 times by 1.2 squared plus 5. Let's put it on a calculator, see what that gives us. Right, and that gives us an answer of 21/5, which is 4.2. So this is basically saying that if I have a width of 2.4, an x value of 1.2, this will give me a height of 4.2. The coach is less than this 4.2. It's going to fit underneath this quadratic. So the conclusion is that the coach will fit under the tunnel. Okay, so what we'd write after this is that it's got a bit of space. So 4.2 is less than 4.1. So the coach can enter the tunnel. And part C, suggest a reason why this model may not be suitable to determine whether or not the coach can pass through the tunnel. Okay, I've given a few reasons here, so you just need to pick one of these because it's one mark. So I put here that the road may not be perfectly horizontal. What you normally find with roads is that they're actually slightly higher in the middle than they are at the edges to allow rainwater to run off. That's called a camber when you have that type of thing in a road. So it's more likely that the road is going to sort of come up slightly in the middle. Another reason why it might be suitable is that the coach would have to be in the very centre of the tunnel. So we're talking about the coach being like dead centre like this. That may not be possible. You know, if there's traffic coming the other way and you've got a coach right in the middle of the road, how's that going to work? So that may not be possible. There may be other obstructions in the tunnel, like cones, things like that. They're going to cause a problem. I've got another reason here. The quadratic may not model all parts of the tunnel. So it may not be that it's exactly this shape all the way through the tunnel. You've got things in there like lights and curbs, things like that. And there's all sorts of reasons why the tunnel shape may actually change. I mean, the tunnel may not be straight, so that's going to be another problem. If it's curved around, then it's going to get stuck. So there may be other reasons, but you can pick any one of these three, I think, and normally they will take any sort of sensible sort of suggestion for this type of question. Question 7. Figure 4 shows a sketch of part of a curve with equation y is equal to 2e to the power 2x minus xe to the 2x. The finite region R is shown shaded in figure 4 and it's bounded by the curve at the top, the x-axis at the bottom and the y-axis on the left-hand side. Use calculus to show that the exact area of R can be written in the form p e to the power 4 plus q, where p and q are rational constants to be found. And just a little note, some students, even when they get to 13, don't know what calculus is. Calculus just means you're going to either differentiate or integrate, and for an area we're going to integrate. And you normally have these little notes here. Solutions based entirely on graphical or numerical methods are not acceptable. Numerical method might be, for example, the trapezium rule. So you're not, if you try and find the answer using trapezium rule, you're not going to get the mark. Or if you use a graphical calculator to try and work out the area and just write down the answer without showing your integration step, again, not acceptable. It's not going to get you any marks. So any question with integration, and I'm going to be integrating this function here, I need to know what the limits are. Now I can see clearly that the limit on the left hand side is 0 because that's the x-axis, the y-axis. I need to find the limit on this side. In other words, I need to find out where this graph is crossing the x-axis, and it will cross the x-axis when y is 0. Okay, so I'll just put down upper limit. This is what I'm working out, and that will occur when y is equal to 0. So upper limit equals y, or means y is equal to 0. So we take our equation 2e to the 2x minus x e to the 2x, and we make that equal to 0. We'll solve that by factorising, so I can take e to the 2x out, and that will leave me with 2 minus x is equal to 0. Now from this, e to the 2x, or e to the anything, is always greater than 0, so that can't be equal to 0. So we take the 2 minus x equal to 0, and that will give me x is equal to 2. So that gives me that upper limit 2. So we'll put that in on our diagram, and now I can do the integration. So I'll be integrating between the limits of 0 and 2, 2e to the 2x minus x e to the 2x dx. Now the first part of the expression, this part is straightforward to do. We can just use the reverse chain rule. So reverse chain rule, because what I call the inside here is linear, it's just 2x. So that means that you integrate the outside, so that will just be 2e, the inside doesn't change, and then you you divide by the inside differentiated. Now the inside differentiated would be 2, you divide by 2, so you're just left with e to the 2x. The second bit is a little more tricky. Over here we need to use integration by parts, because we've got this product here of two different things in maths, basically a polynomial and an exponential. Now when you do integration by parts, you need to make u equal to the x part, so I'll make that equal to x. I mustn't forget about this negative sign, by the way, this minus sign. So that's going to go in between my two parts of my working. So u is equal to x, then the other part you make equal to dv dx. So dv dx is equal to 2x e to the 2x. So du dx, that's just 1. And then v, that's when we integrate e to the 2x, and that will become half e to the 2x using the reverse chain rule. So let's write down what we've got so far. So the first part integrated e to the 2x, and then minus the bit where we do integration by parts, and actually all of this is going to be in brackets so I can apply the limits. So integration by parts, we start with uv, so that'll be half x e to the 2x minus the integration between 0 and 2 of v du dx. So v is this, du dx is just 1, so we've got half e to the 2x. So I'm going to put the half in front of the integration sign, and then I've got e to the 2x. So you should always end up with an easier integral. Okay, and then that whole thing, once I've done the integration, is going to have limits of 0 and 2. Actually, I think I'm going to write it slightly differently. So I'm just going to put brackets around the e to the 2x, that's already been integrated, and then brackets around the first part of the integration by parts here. Right, I'm going to have to move the second bit across a bit, so let's just rub that out. So I'm just putting the limits in what I can put the limits in. I think I still need brackets there because I'm subtracting all of that, and then minus half e to the 2x dx. Okay, so let's work through this. So over here, let's put the limits in. So if I put the limits in, I will have e to the 4 minus e to the 0. Now anything to the power 0 is 1. So that's the first bit. Minus, then I'll put the limits in here. So I'll have half times by 2, which is just 1. And then e to the 2 times by 2, e to the 4. So that's what I get when I put the 2 in, and then I subtract what I get when I put 0 in. Well, putting 0 here, the whole thing's going to become 0, so there's nothing to subtract. And then, oh actually, let's keep the brackets open because I need to do this integration here. So then minus a half, and then e to the 2x integrated is going to be a half e to the 2x. Okay, and then this bit needs the limits putting in 0 and 2. So we should have e to the 4 minus 1, that was the first bit, minus, now we've got e to the 4 minus, and now we put the limits in of 2 and 0. So this is just going to be a quarter. So I've got a quarter e to the 2x, or a quarter e to the 4 when I put the 2 in, quarter e to the 4. Then I'll put 0 in, so I'll have e to the 0, which is 1. So I'll have half times a half, so minus a quarter. Right, let's simplify this and see what we get. So e to the 4 minus 1. Then I'm going to subtract e to the 4. Then I'm going to be subtracting minus a quarter e to the 4, so it's actually adding a quarter e to the 4. And then this minus and this minus will make it a plus, and that will make it a minus. So then the last thing at the end is minus a quarter. So we're going to simplify all of this. So this e to the 4, that negative e to the 4 cancel out, and that will leave me with a quarter e to the 4. That's this bit here. And then we've got negative 1 minus a quarter, so that's minus 5 over 4. So that's the form that they wanted it in. So that would give us p equal to a quarter, and that will give us q equal to 5 over 4. So p is a quarter, q is equal to negative 5 over 4. So let's just highlight those. Question 8. There were 2,100 tonnes of wheat harvested on the farm in 2017. So 2,100 tonnes, 217. The mass of wheat harvested during each subsequent year is expected to increase by 1.2% a year. So we're expecting an increase of 1.2% per year. Part A. Find the total mass of wheat. So total mass of wheat expected to be harvested from 2017 to 2030 inclusive. So you include those years. Giving your answer to 3 significant figures. Now, this is an example of what we call a geometric series, where you have a starting value and we're multiplying to find the next term in the sequence. So we're starting with 2,100. Because it's an increase of 1.2%, you would multiply by 1.012 to give you the next one, and then the same thing again. That would give you an increase of 1.2%. So our starting value, A, is 2,100. Our common ratio, what we're multiplying to get the next term, is 1.012. The other thing that we need to find this sum is the number of terms. And the number of years from 2017 to 2030, including 217, would be 14 years. If you don't include 2017, so if you simply just do 2030 minus 2017, you get 13, but that doesn't include the year 2017. So you could count on your fingers like 17, 18, 19, 20, 21, 22, all the way up to 30, and you would have counted 14. Next, we're going to use the formula to find the sum of n number of terms in a geometric series. And if you don't remember, it's in the formula book, but it's a times by 1 minus r to the n over 1 minus r. You can also use the form where the 1 and the r are swapped around, so you can have r to the n minus 1 and r minus 1. Either form will work. So it's just a matter of substituting those values in. So that will be the sum of these 14 terms is equal to 2100 times by 1 minus r, 1.012 to the power 14 over 1 minus r. Now, using the other form where you have r to the n minus 1 and r minus 1 at the bottom, is that you don't get any negatives, you'll just get a positive divided by a positive rather than a negative divided by a negative. Let's work that out and see what we get. And I have 318, so I'll just write down everything I've got on my calculator. 06.9948. Now it does say that we need to give the answer to 3 significant figures, so we want to sort of round this correctly. So that would be 31,800, and that's to the 3 significant figures as they have requested. Moving on to part B. Each year it costs £5.15 per tonne to harvest the first 2,000 tonnes of wheat, £6.45 per tonne to harvest wheat in excess of 2,000 tonnes. Use this information to find the expected cost of harvesting the wheat from 2017 to 2030 inclusive. Give your answer to the nearest 1,000. Right, well, we know that every year we're going to have at least 2,000 tonnes because we start with 2,100. So we've got 14 years of 2,000 tonnes where it's costing £5.15 to harvest those 2,000 tonnes. So let's work out what that is. And that is 144,200 £. Now also in every year we've got the excess of 2,000 that's charged at £6.45 per tonne. What's that excess? Well, if we take 14 lots of 2,000 away, we work out what the excess is that's going to have this higher cost. So now we're going to do, and I'm actually going to use the exact answer, not my rounded answer. So 31,806.9948 minus 14 times 2,000. And that is 3,806.9948. And this amount is charged at £6.45 per tonne. And it's per tonne, not per 2,000 like before. So I'm now going to do 3,806.9948 and times that by the £6.45 and see what that cost is. So let me highlight the first part of my cost, which is that, and now work out this additional cost. And that's 24,555 and 646, sorry. Let's add these two values together and see what we get. And that is 168,755.14 1165. Now it does say we need to give this answer to 3 significant figures, so we're really only interested in those 3. So that means that 8 is going to get rounded to 9. So to 3 significant figures, that's going to be £169,000. 3 zeros, yep. 3SF. So it's something like that. And that's question 7 done. Sorry, question 8 done. Question 9. The curve C has equation y equals 2x cubed plus 5. The curve C passes through the point P17. Something like that, point P and the equation there. Use differentiation from first principles, so not just normal differentiation. If you did that, you'd get probably very few marks, if any, to find the value of the gradient of tangent to C at P. So the first thing, let's remind ourselves of the formula for first principles. So f dash of x, or dy dx, since we're using dy dx. So dy dx is equal to the limit as h tends to 0 of the change in y over the change in x. So the change in y is f of x plus h minus f of x divided by x plus h minus h. I guess I should use the function notation over here, since it's function notation over here, but you know what I mean. Right, so dy dx is going to equal the limit as h tends to 0 of f of x plus h. So that's going to be 2x plus h cubed plus 5, there's f of x plus h, minus f of x, so just 2x cubed plus 5, over x plus h minus h. Right, let's simplify that down. So the top is going to be 2 lots of this expanded. Now I could expand 3 sets of brackets, but I think the easiest and quickest way is to use the binomial expansion. So very quickly, draw Pascal's triangle. So I know the coefficients are going to be 1, 3, 3, 1, and then all we do is we make 1 power bigger and 1 power smaller as we do the pattern. So it'll be 2 lots of x cubed plus 3x squared h plus 3x h squared plus h cubed plus 5, and then in the second bracket, I'm not going to quite fit it, minus 2x cubed plus 5, and that's all over, well, the bottom will just become x. I'll simplify that. So the top, what am I going to have? Let's expand these brackets here. So 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed plus 5 minus 2x cubed minus 5 all over h. I think some stuff cancels out here, so 2x cubed cancels out, 5 cancels out, so that leaves us with 6x squared h plus 2h cubed, oh sorry I missed one out, 6x cubed h plus 6x h squared plus 2h cubed over h. We'll cancel out the h's before we work out what the limit is as we h tends to 0. So I've got 6x squared plus 6xh and then plus 2h squared, and from here let's work out the limit as h tends to 0, and that will be just 6x squared. Okay, so we can say, so dy dx equals 6x squared. And we know if we did it normally, that's what we'd get. We get 6x squared. So now what we do is we're going to put in a value of 1 to find the gradient at this point P, and then use that to find the equation of a straight line. So we'll say at P, the gradient is 6 times 1 squared. So that's just going to be 6. And now we're going to be using y minus y1 equals mx minus x1 to find the equation of this tangent. So that'll be y minus y1, that's 7, that's our y coordinate, is equal to the gradient, which is 6, and then x minus x1, and that's 1. Now, having read the question properly, I didn't need to do this last bit, did I? They just wanted the value of the gradient to the tangent. I worked out the tangent, so it would help if you read questions properly, unlike me. Question 10. The function f is defined by this. So f is the function, and x is mapped to 3x minus 5, all divided by x plus 1. And what we need to do in part A is to find the inverse. So we start by making it y equals to 3x minus 5 over x plus 1, and we need to make x the subject. So we'll times both sides by x plus 1, so we'll have xy plus y is equal to 3x minus 5. We need to get all the x terms on one side. So we've got xy minus 3x is equal to, and we'll have minus y minus 5. We'll factorise out the x over here, so we'll have y minus 3, and then we've got minus y minus 5, and then divide both sides by y minus 3. Now we could actually write this in a nicer way rather than have minus minus. So you could bring the minus at the front, or you could times the top and the bottom by minus 1. And if we do that, we'll get y plus 5 at the top, and we'll get 3 minus y at the bottom. It's all equivalent. It just gets rid of a lot of the minuses if you just times the top and the bottom by minus 1. And the last step is just to swap the x's and y's around. So we'll have that y is equal to x plus 5 over 3 minus x. So there's our inverse function. Part B, it says we need to show that f of x is equal to x plus a minus 1, where a is an integer to be found. So this is where we're putting the function back into itself. So we have a look at the original function here, and everywhere we have an x, we put the original function in. So it's going to be that f of x is equal to 3, and then where that x is, we put the whole of the original function in. So 3x minus 5 over x plus 1 minus 5 over, and then it will be 3x minus 5 over x plus 1 plus 1. So this all needs tidying up really. Okay, now to tie this up, we're really going to have to get the top all as one sort of type of term, and the same with the bottom, so that we can multiply by the reciprocal of the bottom and get rid of that division. So multiplying the brackets, I'll get 9x minus 15 over x plus 1. But we're also going to write the 5 as x plus 1, so that'll be minus 5 x plus 1 over x plus 1. That means then the whole of the top can be written as a single expression. We'll do the same with the bottom, so we've got 3x minus 5 over x plus 1, and then write the plus 1 as x plus 1 over x plus 1. Then we put the top bits together and the bottom bits together. So the top is all going to be over x plus 1. So I've got 9x and then minus 5x, so that's 4x. Then I've got minus 15, and then I'll have minus 5, so that's minus 20. And I'm going to multiply it by the bottom flipped over. So the bottom is all going to be over x plus 1, so that x plus 1 goes up here now. And then if I put these together, 3x plus x is 4x. And then negative 5 plus 1 is negative 4. So before we do the multiplication, the x plus 1s are going to cancel out. I'll do the answer or the working over here on the left hand side. So that would be 4x plus minus 20 over 4x minus 4. Everything can be divided by 4. So we'll have x minus 5 over x minus 1. So I'll put the answer over here. So it's going to be x minus 5 over x minus 1. So basically a is equal to negative 5. Okay, we'll move on to part C in a moment. I'm just going to clear off all of this working here. Okay, so in part C it says find the value of f g of 2. So just before that it tells us that we've got this new function here, g, where x is mapped to x squared minus 3x, and x is only going between 0 and 5. That's fine because the value that we're putting into g is 2. So remember, the function that's closest to the number, that's what you put in first. So it goes into g first, then f. So we put 2 into g. So g of 2 is going to be equal to 2 squared minus 3 times 2. So that's going to be 4 minus 6. We've got negative 2. And then we put negative 2 into f. So that will be 3 times by negative 2 minus 5 over minus 2 plus 1. So that will give us negative 6 minus 5. That's negative 11. And minus 2 plus 1 is negative 1. So that leaves us with 11. So that means that f g of 2 is equal to 11. Part D, it says find the range of g. So the range of g, that's the values that come out of g. The values that go into g are between 0 and 5. Now, if this was like a straight line, we could just put those two values in. But because it's a quadratic, it may dip down and go back up again. So we need to be careful about working out the range. We want to know what's the minimum value that this gives between 0 and 5, including 0 and 5, and what's maybe the maximum value. So this is going to be like a U-shaped quadratic. And there are various ways to find the minimum of this U-shaped quadratic, because that minimum could be somewhere in between these. For example, I could differentiate. So if I work out g dash of x, that will give me 2x minus 3. The minimum is going to be when this is 2x minus 3 is equal to 0. So that will be 2x equal to 3, and that occurs when x is equal to 3 over 2 or 1.5. So the lowest point that this quadratic goes down to is actually an x value of 3 over 2. Let's work out what the y value is at that minimum point. So we'll just put 3 over 2 into this. So we'll get a y value of 3 over 2 squared minus 3 times by 3 over 2. And that's negative 9 over 4. which is what, -2¼ so that's the lowest point, -9/4. It goes up from that point, being U-shaped, and we want to find what the highest point is. Now we can simply just put in the end values. If I put 0 into the function, that will give me a value of 0 as the highest point at one end. Let's put that in. So none of this is to scale really, so imagine that's going up to 0. And then if I put 5 into this, 5 squared minus 3 times 5, so that's 25 minus 15, which is 10. So it's actually probably looking a bit more like this. That highest point up there is 10. So this quadratic, its lowest point is -9/4, and its highest point is 10. So now we're ready to write down the range of the function. So we'll put down g of x. Now what does it do? It goes up to 10. It includes 10 because 5 is included in x. So up to and including 10. And it goes down to -9/4, including the -9/4. Lastly, part E, explain why the function g does not have an inverse. Now, there are different reasons you can give for this, but one reason is that the original function g is many to 1. Now, I've drawn these blue lines in. It's showing you that two different x values give me the same value, same y value. So it's many to 1. So g is many to 1. If it had an inverse, then the inverse would have to be 1 to many, because everything gets flipped around, which is not a function. So we can have 1 to 1, we can have many to 1, but you can't have 1 to many. So if you found the inverse of a many to 1 function, it would then become 1 to many. That's not allowed. That's not a function. Question 11. Figure 5 shows the sketch of a curve C with equation y equals f of x. The curve C crosses the x-axis at the origin and at the points A and B as shown in figure 5. Given that f dash of x is equal to k minus 4x minus 3x squared, where k is a constant, what we need to do in part A is show that C has a point of inflection at x equals -2/3. Now there are different ways of showing that you've got a point of inflection. One way of showing that you've got a point of inflection is that the second derivative is equal to 0 and the third derivative is not equal to 0. So we'll take the function that we've been given, or the derivative that we've been given, and we'll differentiate it again. So we're taking this here, let's highlight it, and we're differentiating that. So the k will become, well, that just disappeared. The minus 4x becomes minus 4, and the minus 3x squared will become minus 6x. Then what we want to do is to put this point here, the -2/3, into that and see what we get. So we'll work out the the second derivative at -2/3. So that will give us minus 4 minus 6 times by -2/3. So -6 times by -2/3 is plus 4. So we end up with 0, which is what we want. So we've got the first condition. Then I'll differentiate again. Now I'm doing it one way, there are other ways of doing it. So if I find the third derivative, that will just give me minus 6. So the third derivative at -2/3 is minus 6, which is not equal to 0. So it satisfies the second condition. And then we can say, therefore, C has a point of inflection at x equals negative 2/3. Moving on to part B, it says find, let's read a bit before, given also that the distance from A to B is 4 root 2. So let me put that on my diagram. Let's take this out here about the point of inflection. So we have a distance going from here to here, and that distance is 4 root 2 from there to there. And it says what we need to do then in part B is find, showing a working, the integer value of k, that is that value there. So that's what we're trying to find. So 4 root 2 is the distance basically between these roots here, A and B, and if we're dealing with roots we need to know what the equation is. So that means we're going to have to integrate our derivative here to work out, or at least make a start on working out what that function is. So we're integrating k minus 4x minus 3x squared dx. So that will give us kx, then minus 2x squared, and then minus x cubed plus c. So that's our f of x. Now that's the equation of c, and we're told c passes through the origin, so we can put 0, 0 into this and use that to work out what c is. So if we put 0, 0 into it, we will get 0 here, we'll get 0 here, we'll get 0 here. We'll basically get c equals 0. So we can finish off and say f of x is equal to kx minus 2x squared minus x cubed. Now we're going to factorise this because, as I said, we're dealing with roots here, or distances between roots. So if I factorise it, I can take x out. Actually, let me take negative x out, that might be a bit easier, and then I'll have x squared plus 2x minus k. And we'll make that equal to 0 because, as I said, we're dealing with roots. This bit here will give me the root of 0, which is here. So I want to factorise this and get the roots maybe in terms of k, and I've got the distance between them. So let's do that. So yeah, we're just factorising out this part here. And let's have a look. X equal to 0. Now I don't think I'm going to stand much of a chance trying to factorise it in brackets like that. So let's use the quadratic equation, that will make it much easier, I think. So we'll have a equal to 1, b equal to 2, and c equal to negative k. So we've got minus b plus or minus the square root of b squared, so that's 4, minus 4 times a times c, that's negative k, all over 2a, so 2 times 1. Let's see what that gives us. So negative 2 plus or minus square root of 4, I think, then plus 4k. So 4 plus 4k over 2. Right, now the difference between 2 plus what I've got here and 2 minus what I've got here is the difference between these two roots. So I'm going to work out the difference between them. So if I do 2 plus root 4 plus 4k over 2, so that's one root. So to find the difference I subtract minus 2 minus 4 plus 4k over 2, that is equal to 4 root 2. So now it's just a matter of solving this for k. So I can put these two together because they're over the same denominator. So if I do that, I'll have 2 minus 2, which is nothing, and then I'll have a 4 plus 4 k, all rooted, and then minus minus, so it becomes plus. So basically I'll have two lots of root 4 plus 4k over 2 is equal to 4 root 2. So hopefully you've seen how that's happened. 2 minus 2, that's nothing, and then one of these minus minus one of those, so it's plus. You've got two lots of that. It's over 2. As you can see, the 2's are going to cancel out. So that leaves me with the square root of 4 plus 4k is equal to 4 root 2. I'm going to square both sides. So I'll have 4 plus 4k is equal to 4 root 2 squared, which is 32. Then from there, take away 4 from both sides, so 4k is equal to 28. And that leaves me with k equal to 7. So there's my value of k. Question 12, we need to show that the integral of sine 2 theta over 1 plus cos theta between the limits of 0 and pi over 2 is equal to 2 minus 2 log 2. So let's think about what method we could use for this. It's not integration by parts. It doesn't fit any pattern because if you differentiate the bottom, you don't get the top, so that's not going to work. So anything like this, we'd want to maybe use some trig identities, because we've got this 2 theta here, and maybe even like substitution may work on this. So I would start by taking that sine 2 theta and using a double angle. So 0 and pi over 2. So sine 2 theta becomes 2 sine theta cos theta. Again, it's not fitting any patterns. So it's probably going to have to be substitution, I think, on something like this. Now, if it was a pattern, the top would be the f dash of x, and this would be the f of x. And it's like the f of x part that we want to make equal to u. That would be the bottom part there. And that would be much easier. If I try to make the top part equal to u, that's going to be quite tricky to differentiate because I'm going to be using a product rule. So I'll just say let u equal to 1 plus cos x, which means I can just put u at the bottom. Whenever you use substitution, then you need to differentiate. So du d theta would be equal to, well, the 1 will disappear and the cos theta will become minus sine theta. So now we can rearrange that, and then we can say that d theta is equal to negative du over sine theta. And because we have limits, we need to substitute the limits as well. So when x is equal to 0, or in this case where theta is equal to 0, we want to work out what u is. So the way to do that is to put 0 in our substitution. So u will equal 1 plus cos theta, or cos 0. Cos 0, be careful, is 1. So u is going to equal 2, so that'll be my upper limit. And then when theta is equal to pi over 2, u is going to equal to 1 plus cos pi over 2. Now cos pi over 2 is 0, that will give u is equal to 1. So now I have my limits of where I had the 0, I put the 2, and where I had the pi over 2, I put 1. Now don't be tempted to put the larger one at the top. Sometimes the larger one ends up at the bottom because we're doing substitution. And then we've got 2 sine theta, and then the cos theta. Let's have a look. There's more substitution to do as well. So if I take this and I rearrange it to make cos theta the subject, basically I'll have cos theta is equal to u minus 1, Right, so that means where I have cos theta at the top, I'll put u minus 1. At the bottom, 1 plus cos theta, I just put u. Where I have d theta, I'm now going to substitute it for negative du over sine theta. Now what happens is the sine thetas cancel out, not the 2, sorry, just the sine theta. And that will give me this. I'm going to move the 2 to the other side of the integration sign, and I will have u minus 1 over u du, and there's also a minus there as well, that negative, so we'll take that on the other side of the integral sign. So minus 2, and then the integration just becomes this u minus 1 over u. Now, because I've got two things here over the same denominator, I can split them up. That'll make it easier. So I've got negative 2, and then I can write u over u minus 1 over u du. So that's minus 2. The u over u just becomes 1, so it's just minus 1 over u du. We're almost there. So minus 2. Now if I integrate 1 with respect to u, that will become u, and then the 1 over u, that will become log u, so minus log u, or natural log u. And I've left all my limits out. Let's put these back in. So it was 2, 1, 2, 1, 2, 1. So we'll put them here, 2, 1. Now because we have done substitution and we substituted the limits, we don't need to substitute back. We can just put the limits in. So first of all, we'll put the 1's in. So we'll have negative 2, and it will be 1 minus log 1. And then it's going to be minus 2, and then it will be 2 minus log 2. We'll simplify that, and that will give us minus 2 plus log 1. Need to be careful with these pluses and minuses. And then from this bracket here, now this would give me minus 4, and then with that 4 it becomes plus 4. And then multiplying these terms out, this will give me plus 2 log 2 and a minus, so it'll be minus 2 log 2. Now the natural log of 1 is 0, so that's gone. Then we've got 4 minus 2, which is 2, and then minus 2 log 2. Okay, so we've proved it as they wanted, as required. Question 13. Part A. Express 2 sine theta minus 1.5 cos theta in the form r sine theta minus alpha, where r is greater than 0 and alpha is between 0 and pi over 2. So first of all, r, that's basically just equal to the square root of the two numbers squared, so you just do Pythagoras on the two numbers, so 2 and negative 1.5 or 1.5, and we want to give the exact answer as a third, so we're looking at the square root of 2 squared plus negative 1.5 squared, and that gives me 5 over 2, so I'll give that exactly 5 over 2. And then for alpha, alpha is always equal to the tan inverse of one of the numbers over the other. How do we know which is which? Well, we're using sine here, we're writing the form sine, so we need to think about what the expansion of sine would be if we were using one of the addition formula. Now that would go sine cos, and then because it's a minus, it would go minus cos sine. That's what the expansion looks like. Now we have sine, and then a sine there, and a cos there. Now what does that mean? That means that the cos goes with 2, and the sign goes with 1.5, not negative 1.5, because there's a negative there already. So we know that sine alpha is equal to 1.5 and cos alpha is equal to 2. Tan is sine over cos, so that's going to be 1.5 over 2. And we're dealing in radians because it's got pi over 2 there. And I get 0.6435011 and so on. It says that we need to give the value of alpha to 4 decimal places. So R is 5 over 2 or 2.5 and alpha is 0.6435. Right, moving on to part B. Well, actually, before we move on to part B, let's write it fully in that form. So we have that 2 sine theta minus 1.5 cos theta is equivalent to 5 over 2 sine theta minus 0.6435. So that's probably better because this is going to be more useful for the next part of the question. Now it says here, Tom models the depth of water D meters at Southview Harbour on the 18th of September 2017 by this formula here. Okay, I'm not going to read it all out, but you can see that long formula there where T is between 0 and 24. I guess that's the number of hours, 24 hours in a day. Where T is the time in hours after midnight, or 0000 hours on the 18th of October 2017. Part B, use Tom's model to find the depth of water at midnight on the 18th of October 2017. Now, whenever we get these types of questions, always compare what you've got with what we've just done in the previous part. And if I have a look, this part here, I've just worked out something very similar to that in terms of R sine theta minus alpha. The only difference is in the original question there were thetas here, and this has got 4 pi t over 25. So I can just take my thetas that I had and put instead 4 pi t over 25. So what's that going to look like? So the depth would be equal to 6. That's something else that's been introduced that wasn't there before, plus what I got in part A, which is 5 over 2 sine. Now it was theta, because the original question has theta. This has 4 pi t over 25, so let's put that over there, minus 0.6435. We'll probably find this slightly easier to work out the depth at midnight. So at this time here, that will be 0 because we're working out the time at the start. So the depth is going to be 6 plus 5 over 2 times the sine of, right, so if t is 0, all of that becomes 0, so it's just a sine of negative 0.6435. Let's see what that gives us. And I basically get 4.5 meters. There's like another 4 zeros after that, so I can be, rounding it doesn't really make any difference because the number is 0, so 4.5 meters. Moving on to part C, we need to find the maximum depth of the water. Okay, there's actually not much working in this, so if I write it like this, the maximum depth, well, I've got 6, that's not changing, and then I'm adding something to it. I'm adding 5 over 2 times the sine of something. Now this part here, let's highlight it in a colour in yellow. So all of this part here, the most it can ever become is 1. Sine goes between 1 and minus 1. So the maximum depth is just going to be 6 plus 5 over 2 times 1. Because that other bit that I've highlighted in yellow, all of that, the most it can be is 1. If I work that out, that's 6 plus 2.5, so you've got 8.5 meters. If you got a question here that said work out the minimum depth, then same sort of thing applies. All of this bit in yellow here, the smallest it can be is -1, so you just do 6 minus 2.5, so you'd have something like 3.5 meters as the minimum height if they were asking for that. Moving on to part D, it says find the time in the afternoon when the maximum depth of water occurs. Give your answer to the nearest minute. So as we said, the maximum depth occurs when all of this bit equals 1. Let's write that down. So when sine 4 pi t over 25 minus 0.6435 is equal to 1. So we can do the sine inverse of both sides. So we've got 4 pi t over 25 minus 0.6435 is equal to sine inverse of 1, which is pi over 2. So the rest of this is just rearranging to solve for t. So we've got 4 pi t over 25 is equal to pi over 2 plus 0.6435. So let's see, times both sides by 25 and divide by 4 pi. So t is going to equal 25 over 4 pi times by pi over 2 plus 0.6435. So I've effectively just divided both sides by 4 pi and times both sides by 25. Let's see what we get for t as a decimal. Now this gives me 4.4052. Now there's a problem with this answer because it says the time in the afternoon. This is the time after midnight, so this is too early. This is 4 AM. So we need to look for the next value where sine inverse of 1 equals something, or work out the sine inverse of 1. So we've got pi over 2. So I've got like a little graph here to help me. I've got the pi over 2. So let's go to the next solution. Hopefully that will give us the time in the afternoon. So we just add 2 pi to that. So that's like 2.5 pi or 5 pi over 2. So what we're going to do is take those pi over 2's out and replace them with 5 pi over 2. Let's do it in a different colour so you can see the change. So 5 pi over 2 goes here. Pi over 2, change that to 5 pi over 2. So we're basically just using the next solution. And that also means here 5 pi over 2. And let's see if this gives us a time that's in the afternoon. Right, a better answer. So I get 16.905 something. Okay, this is better because it's going to be like 1600 hours. This is going to be 4 PM and something. So we do need to give the answer to the nearest minute. So the whole number part gives us the hour. So 1600 hours, which is 4 PM. You can write 1600 hours. Actually, let's write 1600 because we need to put minutes. So 1600. Now, if we take the decimal part of our answer, 0.905, if you times that by 60, it turns it into minutes because it's a fraction of an hour. And we basically get 54.3121 like this. We need to give the answer to the nearest minute. So 1654 will be the time, or you can write it as 4:54 PM. Part E. Now I've got the answers for parts A to D here in case we need them. So Tom's model is supported by measurements of D, the depth of water, taken at regular intervals on the 18th of October 2017. Jolene attempts to use a similar model in order to model the depth of water at Southview Harbour on the 19th of October 2017, the next day. Jolene models the depth of water H in metres at Southview Harbour on the 19th of October 2017 by this formula. H is equal to 5.22 plus pretty much almost the same as what Tom had here, apart from she's got x, and where he had 6, she's got 5.22. Where x is the time in hours after midnight hours on the 19th of October 2017. By considering the depth of water at midnight on the 19th of October 2017 for both models, explain why Jolene's model is not correct. Okay, so we know that when Tom did it, Tom got a depth of 4.5 meters. Right, let's see what Jolene's one gives us. So depth of water H is going to be 5.22 plus 2 sine, and then x is going to be 0, so it's 4 pi times by 0 over 25, which is essentially 0, minus 1.5 cos 4 pi times by 0, again, which is 0 over 25. Let's see what that gives us for a depth, and that gives us 3.72 meters. So 3.72 meters is not equal to 4.5 meters. Therefore, her model, not her model. Let's get this right. Therefore, her model is not correct. Part 2 of Part E says this, says hence find a suitable model for H in terms of X. So I would say what we need to do is to take Tom's model and just continue it for the next 24 hours. Now his model that we had before was just for T from 0 to 24. So we want to just add on another 24 hours. So we could say a suitable model is, because we're trying to find one for the next day, so H is equal to, now his model started with 6, and then it was 2 sine, and then it was 4 pi t. So let's just do t plus 24 for the next day, and then I guess we could do t plus 48 for the next day, and then minus 1.5 cos, and then 4 pi, and then just add another 24 hours. Because we know that his model works, we just want the next 24 hours basically. And I guess since we're looking at correcting Jolene's model and she's using X, then I guess we should really use X's here. But essentially does the same thing. It's that time after midnight, isn't it? But this is the bit that made her model incorrect, using 5.22 rather than 6. Question 14. Figure 6 shows a sketch of a curve C with parametric equations x is equal to 4 cos t plus pi over 6 and y equals 2 sine t, where t is between 0 and 2 pi. Show that a Cartesian equation of C can be written in this form: x plus y all squared plus ay squared equals b, where a and b are integers to be found. Okay, so this is about eliminating t, isn't it? So let's start with our x part here. X is equal to 4 cos t plus pi over 6. And what we'll do, we're going to expand this. So we get 4, and the expansion for cos. So if we've got cos and here we've got a plus b, that's going to be equivalent to cos a cos b minus sine a sine b. So we'll have 4, and then in brackets cos a, that's cos t, cos b, so that's cos pi over 6, minus sine a, so that's sine t, sine b, which is sine pi over 6. Okay, now the cos pi over 6, so we've got cos t, is root 3 over 2, so we can change that to root 3 over 2, and then minus sine t, and the sine pi over 6 is a half. Right, so what does that become? So if I expand all of this and do 4 times the root 3 over 2, that will become 4 root 3 over 2, or 2 root 3. So we've got 2 root 3 cos t minus 2 sine t. So this is basically what x is equal to. Now y is equal to 2 sine t. Now we've got 2 sine t here, haven't we? So what we can do is we can write x is equal to 2 root 3 cos t minus y. Right, now at this point we want to start looking at what we want to get to. So rather than just saying, right, let's carry on substituting, let's start to try and make this look like this. So I can take this y to the other side, so I've got x plus y is equal to 2 root 3 cos t. Now can you see this is all squared here? So let's square both sides. So then we'll have x plus y all squared is equal to, now we need to square 2 root 3, and that's 12. So we'll have 12 cos squared t. So the last thing we need to get rid of is this, and it looks like it becomes ay squared. Now we can use an identity here because y is equal to 2 sine t. So we can say since y is equal to 2 sine t, so that would give us y over 2 is equal to sine t. Now if we square this, we'll get y squared over 4 is equal to sine squared t, and then we can use the identity sine squared t plus cos squared t is 1, and then we can take that cos squared t out and replace it with 1 minus sine squared t. So let's write this down. Cos squared t is equal to 1 minus sine squared t, which is equal to 1 minus, well, that's y squared over 4. So next step is from here we'll have x plus y all squared is equal to 12 cos t, and that's 1 minus y squared over 4. Multiplying out the brackets, I'll have x plus y all squared is equal to 12 minus, now 12 over 4, that's going to be minus 3y squared, We're almost there to get it in the form that they want. So x plus y all squared, and we move the 3y squared over, so plus 3y squared is equal to 12. So that's the format that they want it in, and so we have worked out that the value of A is 3 and B is 12.